Good afternoon, everyone. I'm Huang from Alibaba Cloud Database team, and today's talk, in this talk, I will introduce a brand new product, POLARDB X. This product will be released on Alibaba Cloud platform in September this year. So this talk, is roughly divided into three parts. First of all, I will introduce what POLARDB X is and what is it for and how it has been evolving in recent years. Then I'll talk about the architecture of POLARDB X and the design considerations leading to the architecture, followed by technical highlights and some important components such as the storage engine in POLARDB X. So POLARDB X is a distributed version of POLARDB. My colleague Mai has just introduced POLARDB in the previous talk. POLARDB was originally designed for cloud users. POLARDB X, on the other hand, was originally designed to serve Alibaba's own business. So before I start introducing POLARDB X, please allow me to introduce the history of Alibaba database briefly. At the early stage of Alibaba, the volume of data traffic online was very big. The database architecture at that time was very simple. Each application was served by only one database instance. As business and data traffic grew, a single MySQL instance is unable to support the application it serves. To suit this issue, we scale up database using commercial database such as Oracle, along with the famous IEEE architecture. In 2009, Alibaba started the annual single-stage shopping festival. This festival changed the performance and costs of our databases. We found out that our business has grown large enough that an IEEE architecture was no longer able to catch up, not to mention its expensive costs. It is in the context that sharding on open source database like MySQL emerged as a reasonable solution. By sharding, we split a huge database along with all its tables into multiple small ones and deploy them in a cluster of community servers. In practice, we heavily optimized MySQL according to how Alibaba business accesses data. We built Elasticity, our own branch of MySQL. To implement sharding, we developed a middleware called Taobao, distributed data layer, TDDL, to route queries to different MySQL instances. The TDDL middleware works very well. It is still using in present day, but it comes with a big cost on maintenance and administration. So we have developed a native distributed database, POLARDB X. As I mentioned earlier, Alibaba databases have evolved from a single server, a middleware of sharding MySQL to the native distributed database POLARDB X. In POLARDB X, we use the shared Nelson architecture to achieve a high level of scalability. We aim at processing a huge scale of data. In the meantime, applications of Alibaba business have been deployed into multiple regions. This demands our system have the capability of remote disaster recovery across different regions. In the middleware solution, database administrators need to predict the workload volume in priori and plan the deployment of databases accordingly. If the prediction is inaccurate, databases will have to be scaled out in production. That's causing significant costs of our database, of relocating all the data. Building distributed processing capability can solve this problem. It can auto scale with increasing throughput on demand. So events like a single-stage festival brings another problem. For example, during the promotion day, user requests may increase tremendously. If you scale the database by adding more servers, like the left diagram, it will also loss of storage, because you don't need that much of storage in one day. On the contrary, if in the non-permission days, there are much less user requests and much less demands for the computation power. If the computation and storage are coupled in the same server, we have to scale both of them together proportionally while scaling the database. For this reason, we are determined to decouple the computation layer from the storage layer and scale each of them independently. POLARDB X is our solution in this problem. It consists of two layers. One is XSQL, a SQL engine compatible with MySQL. Another layer is a distributed storage engine layer, X server cluster. In this cluster, a group of X server makes up a high availability replication group, storing some of the data shards of the cluster. The global management service on the right corner determines which data shards our replication group stores and manages. XSQL gets the distribution of data shards from the GMS and catches it locally. It dispatches the execution of SQL queries according to SQL queries to the specific X server according to the distribution information. Usually, each X server contains a plain executor. Using this executor, XSQL may push down the execution of SQL commands to a single server to reduce the network traffic. The GMS server cluster itself a replication group. It reuses most parts of an X server, with a major exception that it only stores the metadata. GMS also provides a node management and scheduling service to achieve a workload balance. So, the architecture of POLARDB X embodies flexible scalability. After decoupling the XSQL cluster from the X server cluster, we can scale them out independently. And high availability, we achieve a strong data consistency within each replication group using the Paxos protocol. We optimize the Paxos protocol in POLARDB X. It allows us to achieve a high level of throughput, even in geo-distributed deployment. As a distributed database, it is important to support the distributed transaction processing. To increase scalability, we apply the hybrid logic clock to assign time steps to each transactions instead of using closed centralized transaction manager or a time step or oracle. Or we assume distributed transactions only account for a small portion of the entire workload. Thus, we introduce a special optimizations for one phase commit transactions to increase the overall throughput when most of transactions can be handled in a single server. So as the final part, I will introduce the design of our storage engine named X Engine. We designed the X Engine based on our observation of online basis workload. The left finger shows our online trade system database query access pattern. The data access are unevenly distributed in a very large storage. A trade record is often only accessed frequently within a few days after its creation, and barely accessed at all afterwards. Many other bases share the same temporal locality pattern. Thus, we partition the storage into multiple tiers for data with different temperatures. This design allows us to use different modern storage devices for different layers. So here's the architecture of X Engine. We use refined algorithm tree to implement the X Engine because the structure is a natural choice for this tiered design. So how we refine it? Basically, we have applied a series of optimization in X Engine to improve the performance to read and write. we have a reduced size. So we have implemented a pipeline to process writes in main memory and enable write requests execute in parallel. Each XM tree in X engine consists of a hot data tier and cold data tier. The cold data tier is further partitioned into different levels and organize data in a tree-like structure. With each level of the tree-story sorted sequence of extents and extents packaged block of records, as well as their associated filters and indexes. Another big problem is compaction. LSM tree relies on compaction to regularize and discard all data regularly. Compactions are very expensive. It costs also CPU and I/O. To reduce the cost of compaction, we utilize the spatial locality of database in the data in the database and propose to reuse unmodified data as much as possible during the compactions. I won't dig into deeper of all details of X engine. This piece of work has been accepted by Sigma Conference Industry Track, and we are about to introduce the details of X engine Sigma this year. We welcome you reading our X engine paper if you are interested, and during our discussion in Sigma this year. So this is all I talk, and you can download the X paper by scan the QR code. Thank you all.